The following audio recording has been designed for learning purposes only. Do not share, distribute, or provide any type of copies, or this audio lesson will not be made available to you. Good luck with today's lesson.
Material-wise then, so anything we talked about last week that you have questions on? No? Okay. Okay, then as far as the textbook goes, we are in section 2.5. So we're going to start solving equations with fractions and decimals. We did a little bit of this last week. We're going to spend a little more time with it now. Okay, so I don't like that example. So if we want to solve this, if I have, say, 1/4 x plus a half is equal to 5/8. Okay. I mean, you can go through and deal with it like this. There's nothing wrong with that. But as we said last week, there's kind of a simpler way we can go about it, which is we can find the LCD for all the fractions here. So all the denominators, we've got 4, 2, and 8. So our LCD here is 8. Then if I multiply through both sides by 8, what that'll do is it'll clear the fractions out, and then we're just going to be dealing with integers. So to solve these, then, one, we want to find the LCD. And then two, we're going to multiply both sides by the LCD. Okay. What that'll do, as I said, that clears the fractions out for us, and then we're just dealing with integers. So in 3, we just solve as we normally would. Okay. So in this example, the LCD is 8. So I'm going to multiply both sides by 8 here. Okay, so we're going to do that. Over on the left here, we have to distribute. So I would have 8 times 1/4 x plus 8 times a half is equal to, well, here, I can rewrite this, 8 over 1 times 5 over 8. So 8's drop out there. Here, I could rewrite this as 8 over 1 times 1 over 4x plus 8 over 1 times a half. And here, that's simplified to 5. And now I'm just going to simplify these. 4 drops out, and this will be a 2. This 2 drops out, and this will be a 4. So then I have here, that's simplified to a 2x plus, and then that's 4, and this is equal to 5. Now we've got this equation, and this is a lot nicer to work with. We just go ahead and solve this now. So just go ahead and subtract 4. So then I would have 2x is equal to 5 minus 4 is 1, and then just divide by 2. Okay, so the answer here we get is 1/2. So if we see something with fractions like this, it'll be a lot easier to solve it if we get rid of those fractions. And you do that by multiplying both sides by the LCD there. Okay, so any questions on this example here? Is that okay? All right, let's try another one then. Everybody have this? Okay. So this equation, same thing. Really the same thing. LCD is what? 8, just like the last example. Try and pick a different one next time. So our LCD here is 8. And just going to multiply both sides by the LCD. So it's 8 times A plus 3/4 is equal to 8 times 3/8 A minus a half. And then on both sides, we just have to distribute. So this first term is just 8a, and then plus, I'm going to write it like this. 8 over 1 times 3/4 is equal to, and then distributing on the right, this would be, I'll write it as 8 over 1 times 3 over 8a minus 8 over 1 times a half. And then just want to distribute, I'm sorry, not distribute, simplify here. So that 4 drops out, and that is a 2. These 8's cancel, and this 2 drops out, and that is a 4. Okay, so now I would have here 8a plus, here this would be, I would have what left over? 2 times 3, that's 6. Here, that all simplifies to just 3a. And then here, this would be minus 4. Okay, so now I've got that equation, and that's pretty straightforward. So we're just going to go ahead and solve this. Subtract 3a from both sides. So 8a minus 3a, we get 5a. Plus 6 is negative 4. And just continuing on, subtract 6. So 5a is minus 10, and then divide by 5. So we get a is negative 2. So this makes dealing with equations that have fractions in them much simpler. So that's something we want to go and take advantage of. So let me give you an example to try here. Okay, go ahead and solve that and see what you get. Okay, how many people got an answer here? Negative 1? How many people got negative 1? Okay, good. All right, so again, first thing, we're going to find the LCD and multiply by it. LCD here is 6. So we're just going to multiply both sides through by that. On both sides. So we're just distributing here, so it would be 6x plus 6 over 1 times a third is, and then over here, 6 over 1 times 1 over 6x minus 6 over 1 times a half. And then just simplifying all this. So we get 6x plus 2 is equal to, this term is just x, and then that is minus 3. So we have this. Put that in room. So, going to subtract 2 from both sides, and then I have 6x is equal to x minus 5. Then subtract x. And we get 5x is equal to minus 5. So we get that x is negative 1. You can see that. Sunlight's not helping right now. So any questions there? Okay. Okay, let's try some different ones. Okay, so this one looks a little bit different, but it's still the same exact idea. We've got fractions, so I want to multiply both sides by the LCD to get rid of them here. Again, LCD here is 6, so I'm just going to multiply both sides by that. So I would have 6 over 1 times, it's 4y minus 7 over 3 is equal to 6 over 1 times y over 6. Okay, so here my 6's drop out. And then here, that simplifies. This is just 2. So now this is 2 times this whole quantity here. So it's 2 times the quantity, 4y minus 7, is equal to, this side simplifies to just y. So we've got this. And now we just want to solve this. So distributing the 2, this would be 8y minus 14 is y. Subtract y there, so now we have 7y minus 14 is 0. And then I'm going to add 14 to both sides. So we have 7y is 14. Divide by 7, and we get 2. Okay, so any questions that? Okay. similar to the last one, but now we've got this extra term here, plus 6. That doesn't change a whole lot as far as our approach. Again, we're just going to multiply both sides by the LCD, which in this case is 8. So I'm just multiplying both sides by 8 here. I would have 8 times, this will be 4q plus 3 over 2 plus 6 is equal to, I can write this as 8 over 1 times 3q plus 5 over 4. Here I can simplify this. 4 drops out and this 8 will simplify to a 2. Over here I have to distribute, so I can write this as 8 over 1 times 4q plus 3 over 2 plus 8 times 6, I get 48. And this is equal to, over here it's 2 times this whole quantity, 3q plus 5. So 2 times 3q plus 5. Okay, so I've got this. I'm going to simplify over here. That 2 drops out and that 4 simplifies to an 8. I'm sorry, that 8 simplifies to a 4. I had that backwards. So now we have this. It would be 4 times 4q plus 3 plus 48 is equal to, and here I'm going to distribute the 2, so this will be 6q plus 10. Okay, so now we've got this. It's looking a little bit better now. I just have to distribute here as well, and then we'll be on our way. Okay, so any questions up to this point here? Is this all fine? Okay. So distributing that 4 then, it's 16q plus 12 plus 48 is equal to 6q plus 10. And then the 12 and the 48, that is 60. And now we just want to solve this. So that is 10q plus 60 is 10. Subtract the 60, and it's 10q is equal to negative 50. Then divide by 10. So we get negative 5. Okay, so no questions here? Okay. So as far as decimals go, I'll do a couple examples there. So we did one of these before. If I want to solve this, say 0.06x, plus 0.02 is equal to 0.25x minus 1.5. So again, we prefer not to work with decimals, just, in the same way we don't really want to work with fractions as well. So to get rid of the decimals, well, I look and see, well, how many decimal places do I want to get rid of here? Well, I've got 2 places here, here, and here. There are only 1, but that means, overall we need to get rid of 2 decimal places, right? And before we said what we're going to do then is, for each decimal place that we want to move over, in this case 2, we multiply by a factor of 10. So we've got 2 places we want to move here, so we want to multiply by 2 factors of 10. 10 times 10, that is 100. Okay, so it's the same idea actually as multiplying both sides by the LCD. We're just moving decimal points here. So for each decimal place, we need to move right, multiply by a factor of 10. Okay, and in this example, since we want to move 2 spaces right, that's 2 factors of 10, or 100. And then once you've done that, that'll get rid of the decimal places, and then you just solve. Okay, so the equation is 0.06x plus 0.02 is 0.25x minus 1.5. Okay. And we want to move our decimal place 2 places right, so we're going to multiply by 100 on both sides. Okay, so when we distribute on each side, all that's going to do is move the decimal place over 2 places. So here, this 0.06 will just become a 6. This 0.02 will just become a 2. This 0.25 will be 25. And the minus 1.5, well, if I move it over 2 places, I'm going to have to put a 0 in there. So this will be a 150 here. So I would have 6x plus 2 is equal to 25x minus 150. Okay. Now these are all integers, so we can deal with that. So I'm going to subtract 25x here. And 6x minus 25x, that'll be a minus 19x plus 2 is equal to minus 150. Then subtract 2. So I have minus 19x is equal to minus 152. Divide by negative 19, and you get x is 8. Oops. Okay, so go ahead and try this one out. So it'll be the same method that we just used here. So let's see, try this, 0.65k minus 0.1, 0.4k minus 0.35. Okay, so go ahead and solve that same way we just solved the last problem. Okay, how many people got a solution for this? Okay, what do we get? Negative 1. I didn't do that on purpose. I know the last one I asked you to do is negative 1. Yeah, you should get negative 1 here. So, first thing we do is what? Yeah, I'm going to multiply both sides by 100 because I want to move the decimal place 2 places. That'll get rid of all my decimals here. So I can just count. I go 1, 2, so this will be 65k. This one here will be minus 10 because I have to add a 0 after that. Same thing here, I have to add a 0, so this will be 40k on the other side. And then when I move this over twice, this will be minus 35. So we've got this. And now we just go ahead and solve it. This isn't too bad. So I'm going to subtract 40k from both sides. We get 25k minus 10 is minus 35. Then add 10. So 25k, whoops, is minus 25. So you get k is minus 1 for that. Okay, any questions there? Seems all right. Okay, so that's how we deal with fractions and decimals, so you'll see plenty of that in your homework. So we'll wrap up that section. We're going to move on. Before we jump to the next section, though, let me go ahead and take attendance real quick, and then we'll move on. Ashik Antu? Ashik? David Borthwick? David. Ashley Burkle? Ashley. Angelina Cardinelli? Caleb DeRuin? Caleb? Okay. Hiba Elturk? Hiba? Kyle Ferrito? It was Kyle, right? Ian Gardner? Maksuda Agori?
Yeah.
Okay. Emier Gilmore? George Gluth? George? Okay. Caitlin Harrison? Bridget Healy? Bridget. Maggie Haimedi? Nevin Jabbar? Silas Johnson? Tafia Kanome? Laura Lonachak? Saida Mehmedi? Delina Middlestat?
Here.
Kiera Middlestat?
Yeah.
Narissa Mullen? Nat Nguyen? Maya Palmer? Mina Petrus? Mina? Okay. Zachary Patiglio? Zachary? Selena Rawalt? Selena. Pedro Sacconi? Victoria Storm? Dina Tran? Dina. Hung Vong? Pierre Ward? Ethra Yalda? Nada Yusuf? And Isla Zrenek? Isla. Okay. Okay, so in section 6, what we're going to see, this is about, I've basically got a formula involving maybe a few different variables, and I want to be able to solve for one variable in terms of others. Okay, so our solutions here are not necessarily going to be numbers. Basically, this is going to be symbol pushing. We want to rearrange things to get an appropriate relationship with for one variable in terms of the others. So in section 6 here, we want to be able to solve a formula for some variable. Okay. And a basic relationship here. So some of these things we'll see kind of again and again. Some of these formulas are just going to be one-offs. I just kind of throw a formula at you and want you to be able to do some algebra. But this is a relationship that comes up a lot. So it's involving distance, rate, and time. Which is very simple. Basically, we have that distance. Okay, so say you're in a car, you're on a bike, you're traveling at some specific constant speed for a certain amount of time, and you do that, you travel some distance. Okay, and the distance you travel is equal to the rate or speed that you are traveling at times the length of time that you're traveling at that speed. So we have this basic relationship here that distance is equal to rate times time. And rate is your speed, say in meters per second, miles per hour, whatever. More briefly, we would often just write that d is equal to r times t. Okay, so just using some variables there. D is distance, r is rate, and t is time. Okay. So this will pop up a lot of times when we're talking about movement problems or problems involving distance and time and speed. Okay. So this is a very basic relationship that we'll see pop up pretty regularly for some applied problems. Okay. Okay, so very simply then, let's say Joe travels at 25 miles per hour for 3 hours. How far did he travel? Okay. This is very basic here. We're basically just plugging these things in. The rate is the speed here, 25 miles per hour. The time is obviously the 3 hours. So all we have to do to get the distance is just multiply these together. Now, often we want to pay attention to the units here, so I'm actually going to do that. So we have d is equal to, well, the rate is 25 miles per hour. I'm going to write it like this, 25 miles per 1 hour. And then times my 3 hours, I could write it as 3 hours just over 1 like this. So now my units cancel, hours cancel here. So it's just 25 times 3, and then I have units of miles left. So this would be 75 miles in that case. Okay. So here I'm mainly demonstrating, pay attention to units. A lot of times if you just get your units correct, that's going to be a good indication you got the right answer. So a lot of times just paying attention to units, you can go pretty far with that. So that's something to pay attention to with these problems. So this is a basic relationship here. Now, sometimes we're going to be interested in coming up with a formula or solving for one quantity in terms of others. Okay, so let's say I want to solve d equals rt for t. Okay, so I have this basic relationship here. I want to solve it for t. Okay. Well, that's pretty straightforward. I have d is equal to rt. Well, t is here, and this is r multiplied by t. So if I just divide both sides by r, I'll get t by itself here. Okay, so for d equals rt, we're just dividing by r. So then we get that t is equal to d over r. So in this case, what we're saying is that time would be equal to the distance traveled divided by the speed you were going at. Okay. And that would tell you how long that you had traveled for. Okay, so this is a simple relationship here. We can have things that are a little more complicated. So let's say I have this. A is equal to 1/2 b times h. And I want to solve this for h, let's say. Okay, so I've got this relationship here. Okay, so a equals 1/2 b times h. Okay, well again, in this particular example, we've got that fraction of 1/2. And let's get rid of it. So to do that, we're going to multiply both sides by 2 first, just to get rid of that fraction. I mean, I want to do that because I want to get this h by itself, so I need to get rid of that factor of 1/2 too. Either way, I want to multiply both sides by 2. So when you do that, you get 2a is equal to, this would be, well, 2 over 1 times 1/2 bh. 2's drop out. So we have 2a is equal to b times h. Now all I have to do, well, getting h by itself, well, these are multiplied together, so all I have to do is divide by b. So then we get h is, it would be 2a over b. Okay. Another basic relationship that we'll see from time to time is calculating simple interest. So like you put money into a savings account or something, you let it sit over time, and it's you've got some interest rate attached to the account that you have. Okay, so you collect interest over time. Okay, and in this case, again, a simple formula. What we have is that the interest you would earn, it's equal to the principal. And principal, that's just the amount of money you put in the account to start with. So say you put $1,000 in your savings account, and then it starts accumulating interest over time. That $1,000 is the principal. It's just the initial amount of money you put into the account. They call that the principal. And then we multiply by the rate. Now here, rate, in this case, is just going to be a percentage. You're earning some percentage over time. So like, say, 5% per year or something like that, or 12% per year, or these days it might be 1.5% per year because interest rates are really low. So in this formula, rate has a different meaning than the distance formula. In the distance formula, rate meant speed you were traveling at. Here, this means interest rate, which is always going to be a percent. And when we're doing calculations with percents, we have to remember when we actually do the calculation, we need to change the percent into a decimal number. So that's something we want to keep in mind as well. And then we also multiply by the amount of time that the money is left in the account and it's accumulating interest. Okay. So we've got this formula here. So we'll often just write this as I is equal to PRT. Okay, so that's our simple interest formula. So let me just do an example with this. So suppose, oops, that's an O. Suppose Sam puts $2,000 into a savings account that earns, let's say, 6% simple interest. Okay. After 2 years, how much interest has she earned? So this example, again, it's very straightforward. We're told the principal, that's the 2,000. We know the interest rate, that is the 6%. Now we'll need to change that to a decimal number, so 6% we would want to write as 0.06. And then we know the time as well is 2 years. Oh, also, for this simple interest formula to work, time always has to be in years. So if they give it to you in, say, months or weeks or anything, you need to convert that into years as, a fraction of a year or something like that. So if it was, say, 3 months, to put that in terms of years, you would write it as the fraction 3 over 12, right? Because there's 12 months in a year, so write it as 3/12. Okay, so T must be in years here. So T in years. Okay, so we're just plugging in the principal, the rate, and the time, and then we just multiply those numbers together, and we get the interest here. So we would have I is equal to, this would be $2,000 times 0.06, so I'm writing the interest rate, the percent, as a decimal, and then times the years, which is just 2. So just going to go ahead and multiply those out. So it's 2,000 times 0.06 times 2, so that is $240. Okay. So that would be the interest earned over those 2 years. Well, if that's how much interest she earned, what would the total amount in the account be then after those 2 years? Yeah, you just add this to the original principal, so then we would say the amount in the account is the $2240. So then total in the account is the $2,000 principal plus the $240 in interest, so it's $2240. Okay, so just a simple example for simple interest here. Let's go ahead and take a short break, 5 minutes or so. We'll come back and we'll do some more solving for variables in terms of other variables. So let's say I want to take this formula, so I equals PRT, our principal formula, or our interest formula, and let's solve this for P. Okay, so we want to rearrange this and get p by itself. Well, so we have I equals PRT. Well, R and T are both multipliers here, so all I'm going to do is just, well, divide both sides by R times T, like that. So now P is I divided by RT. So we've got that relationship here. So this would be if we had a problem where we knew the amount of interest that was earned and what the rate and the time were, we could figure out what the original principal was in this case. So as an example there, let's say, let's find P when I is equal to $2,160. R is 6%, and T is 3 years. Okay. So we already have a separate formula for P, so all we have to do is now just plug all this stuff into this new formula we came up with, and we can do our calculation. So P is equal to, that is 2160 divided by, and then it's RT, so R is 6%, so again that would be 0.06, and then T is 3. Okay, so we're just going to go ahead and calculate that. So we have 2160 over 0.06 times 3, so you should get $12,000. Okay. And simple interest will come up again from time to time. That's another common relationship that gets used, especially if you go take business math or like a finance class or something. You'll definitely see a lot more of that. Let's look at some other examples, though. So let's say I want to solve, say I have 3x plus 2y is equal to 18. And let's solve for y when x equals 4, and then for y in general. Bless you. Okay. So we're going to do it twice here, basically. Once when x is 4. Well, when x is 4, that just means we're going to plug in x here and then solve for y. That'll be a simple enough relationship. So we're going to do this first. So when x is equal to 4, we would have 3 times 4 plus 2y is equal to 18. So 3 times 4 here is 12. So I have 12 plus 2y is equal to 18. Subtract 12. So then I would have 2y is equal to 18 minus 12 is 6. Then divide by 2. So we get y is 3. Okay. So for this equation here, when x is equal to 4, we get that y has to be 3. Now, solving this in general for y, all I'm going to do is take this equation here and just push symbols around to get y by itself. Okay, so this was a specific example, and now we're basically going to come up with a specific formula just for y by itself. So we have 3x plus 2y is 18. And since I want to get y by itself, first thing I'm going to do is subtract 3x from both sides. So I would have 2y is negative 3x plus 18. Now I just want to divide both sides by 2. So I'm going to divide by 2 here and here. So here I would break this up as, I could write it as minus 3 halves x plus 18 divided by 2 is 9. So we have this. Y is equal to minus 3 halves x plus 9. Okay, so this is our general formula for y in terms of x now. So this will give me any value of x that I pick, I can compute y directly. So we can check that. So previously we said, well, what happens when x is 4, we computed y is 3. If we plug x equals 4 in here again, we'll actually be able to just compute y directly. And we should get 3. Was it 3? It was 3, right? Yeah, it was 3. Okay. So again, let's use this to get y when x is 4. And we'll see we get the same thing here. Okay. So now we're just computing it directly. So y is minus 3 halves times x, which is 4. So I'm going to write that as 4 over 1 and then plus 9. So here, 2 simplifies. That becomes a 2. So I have negative 3 times 2. That's minus 6 plus 9 is 3. Okay, so we get the same thing again. So that's why it can be useful to kind of come up with these new formulas, because sometimes we might want to calculate a certain quantity multiple times just with different x's, or whatever your different variables are. So rather than having to kind of put it into the original equation and solve it new every time, we can come up with these general formulas, and then we can just do a straightforward computation if this is, say, something we want all the time. Okay? That happens a lot. I mean, for almost any field you're in. I took a lot of physics when I was in college, and we were always trying to get some quantities in terms of another. And we were always solving formulas for certain variables, and then we would just do these straightforward computations here. So let's just do some more examples where we want to solve for some variables in terms of others. So why don't you go ahead and try this one. So go ahead and solve, say, 6x plus 5y is equal to 30. Go ahead and solve this for x. So take a moment and go ahead and do that. Okay, who has an answer here? Yeah.
Is it 5 minus 5y?
I'm sorry?
Is it 5 minus 5y?
5 minus 5y, not quite. Yeah.
5 minus 5 over 6y.
Yeah, so you should get, we'll go through it. You should get this. Or if you wrote as 5 and then minus this, that's also okay. Okay, so we should get this. Okay, so we're starting here. So 6x plus 5y is equal to 30. Now we want to solve for x, so I want to get x by itself here. So starting out, I'm going to subtract 5y from both sides. So then I would have 6x is equal to minus 5y plus 30. And now to get x by itself, I just need to divide both sides by 6. So I'll get x is, this I can break up, it would be minus 5 over 6y plus, and then 30 over 6 is 5. So we get this, minus 5 over 6y plus 5. So that's our relationship when we solve for x in terms of y here. Okay, any questions on that?
So if I'm understanding this correctly, you isolate the variable that you're trying to solve for by subtracting the other variable from itself
Yeah.
and then dividing.
Yeah, so what you're doing here is you look and say, okay, what term has the variable I want?
Okay.
In this case, it's this term. Now the term is 6x. So first get this term by itself. Now to do that, you know, we've got a plus 5y here, so you subtract it. So you get, so the variable you want by itself, first you look at, okay, well what term has that variable? Just get that term by itself first. Do that by adding or subtracting in this example. And then we had one more thing to do. It's like, okay, well now I have the term 6x is equal to minus 5y plus 30. I still want 6 by itself, or I'm sorry, x by itself. We'll add this multiplier 6 here, so then you divide both sides by that. And then you get this.
Okay, that makes sense.
Any other questions? Okay. So that's most of section. That's pretty much section 6. So in this last section in chapter 2 here, we want to solve linear inequalities. Okay. Okay, so a linear inequality in one variable is any inequality that can be written as, say, ax plus b is less than c. Okay. Or this could be greater than or less than or equal to, or greater than or equal to. So I mean, any of these symbols here. So anything that could be reduced to, I'm not going to rewrite these all here, but basically something like this. Okay, so ax plus b and then an equality sign and then a constant there. So anything that can be written like that, that's a linear inequality in one variable. Okay, so what we're going to find when we solve these, a lot of the time, when we had equations, if we had a solution, we would get one solution, right? We talked about that last time. We either get one, none, or infinite solutions. Here, for most of these, what we're going to find is that we get whole intervals on the number line. So there'll be whole sections of the number line that will be solutions here. Okay. So for that, we want to see how do we write down and interpret what these solutions are. So before we go about solving these, we're going to talk about what the solutions look like and how we kind of write those down. So first we're going to look at how we graph inequalities on the number line. Okay, so for example, suppose I have some inequality and I get it down to something like this. So suppose I have x is greater than 2. Okay. What does this mean? What does it look like? Well, it means that our variable x, our solutions we're interested in are all numbers that are greater than 2. Okay, so graphically what we're going to do, we're going to draw our number line. So for this, normally, we think of 0 as somewhere, numbers going to the right, that's the, positive direction. Moving to the left would be the negative direction. So we're increasing if we're going this way, and we're decreasing if we're going that way. Okay. Let's say 0 is here, and then I've got, say, 1, 2, 3, etc. Over here, say -1, -2, -3, etc. like that. Okay. So then graphically, if I want to interpret this, well, x greater than 2, well, here's 2, and I want everything greater than that. So that means I really only care about everything, in this case, to the right of 2 here. Okay. So I'm only going to be interested, does this one work? Okay. I'm only going to be interested in everything larger than 2. So what you do then is you would shade or sketch in, however you want to do it, what satisfies this. So that's everything greater than 2. Okay. Now we want to pay attention to the symbol here. Now this is a strict inequality, right? This is just greater than. It's not greater than or equal to. What that means is, well, since it's not or equal to, that means 2 itself does not actually satisfy this inequality here. In other words, it's not a part of the solutions here. In this case, it's the lower bound, right? Because we care about all these numbers, from 2 off to positive infinity, as large as you want to go. But not actually 2 itself. It's just the boundary here. Okay? So you can get as close to 2 as you want, but without touching it. Okay? So it would be 2.1, 2.01, 2.001, 2.00001, but not actually 2. Okay? So to denote that, on here we use a certain notation. So to show that we're not including 2 as a part of our solution here, we'll use like a parentheses, basically, going in that direction. So this is a common notation. Another one that we might see is an open circle. So a circle, but it's not filled in at 2. That's another very common notation. So these parentheses here, or an open circle even, but then everything shaded to the right like that. And what this means is I care about these numbers, or this interval here, so everything greater than 2. Okay. And then, very similarly, say x is greater than or equal to 2. Well, now, this basically is the same, only difference is, for this, now we also say, well, 2 is also included. So 2 is a part of our solution now, and everything bigger than 2. So on our graph here, to show that we would include this point here, 2, instead of a parentheses, we would actually use a square bracket here, is what we would do, to show that that number at the boundary, it's actually included. It's a part of our solutions, is what we would be saying. So graphically, to show that, it's the square bracket is what we use. So for this inequality, the solution would look like this. Okay, so it's almost the same, a little bit different. So let's say 0, 1, and 2 is here. And again, we're taking everything above 2 in this case. But since we're also including 2 because we have the or equal to here, I use a square bracket. Okay. So that tells us that we also include the number 2 and everything larger than 2. Okay. And also another common notation, well, here they used an open circle to show we're not including 2. Another notation that's very common is to use a closed circle, and then you would shade everything above 2 there. Okay. So these are both very common notations, the parentheses and the square brackets, also the open and closed or filled in with a circle there. I kind of prefer the parentheses and the brackets because when we start talking about using what we call interval notation, we reuse the brackets and the parentheses here for when we're actually writing other things down. We'll get to that in a little bit, though. But these are both very common notations, so I just want you to be familiar with both of those. Okay, so this is when our solution is strictly greater than some number. This is when it's greater than or equal to. Well, if it's less than or equal to, it's a similar idea, but the graph is a little bit different. So suppose, now I've got this, let's say that x is less than, let's say, 1. Okay, so same thing. Say 0 is here, 1, 2, -1, -2. Okay. Well, here's 1. Now we only care about numbers that are less than 1. So here's 1. Less than is everything to the left there. Like that. So we would take all that stuff. And again, since this is a strict inequality here, we again would use the parentheses notation to show that in this case, 1 is the upper bound, right? Because everything is less than 1 here, but we are not including the actual number 1. You can get as close as you want from below, so 0.9, 0.99, 0.999, etc. like that, but not actually equal to 1. So you use the parentheses notation there to show that. Same thing with, if you have x is less than or equal to 1. Okay, so again, we want everything less than 1, so that is to the left. And since we have the equality part here, or equal to, we can use the square bracket notation to show that we are including that number. So 1 is now a part of this solution. Here, 1 was not a part of that solution. Okay. So instead of always drawing these graphs here and these inequalities, we can also use interval notation. So let's go back. What do I have? X was less than, was it 3? Anyway. So if I have this, x is less than 3, the graph here was this. Oh, wait. I wanted greater than 3. X is greater than 3. Or whatever I had. So here's 0, 1, 2, 3. And we use the parentheses there, and then we're shading everything to the right. Rather than always, say, drawing our graph out here, we introduce interval notation. Well, we're interested in numbers that are larger than 3 but not including 3. So we can write our solution like this. I would write 3 and then positive infinity like that. This looks kind of similar to this graph here. Again, when x is greater than 3, what this is telling me is I want numbers from 3 to infinity. So that would be everything bigger than 3. And again, I'm using the parentheses notation here to show that 3 is not actually included in this set of numbers here, this collection of solutions here. Okay? Again, it's the lower bound, but it's not actually part of the solution. You can get as close as you want, 3.1, 3.01, all that, but not actually equal to 3. And this interval notation is kind of looking like these graphs here. It's 3, then everything bigger than that, well, to the right would be off towards positive infinity in this case. And then if I had an or equal to here, I would just change this to a square bracket. So if I had x is greater than or equal to 3, again, my graph, let's say 0, 1, 2, 3. So we use the square bracket and all that. If I'm writing interval notation, this would be bracket 3 to infinity. Okay. Oh, and for the infinities, we always use parentheses for these because we think of it as you never actually get to infinity, you're just always heading in that direction. So the proper notation for infinity, and in a minute we'll see negative infinity, you always put a parentheses on that. And then for x less than 1, we had this. So then let's say that's 0. This is 1, negative 1. So in this case, the interval looked like this. Now, well, before the 3, this was the lower bound. Well, now, the number we're interested in here, 1, this is actually the upper bound. So this interval, well, off in this direction, this is off towards negative infinity. So I would put the negative infinity first, and then this upper bound here, in this case the 1. And again, I would use the parentheses notation with that. So I would write this as parenthesis minus infinity to 1 with the parentheses there. Okay. And again, that just shows that we are not including the number 1 there. It's just the upper bound for all the numbers we are interested in. And then for x less than or equal to 1, the graph, here's 1, 0, negative 1. Use the bracket there, and I shade all that. And the interval then is negative infinity to 1 with the square bracket there. Okay. So this is our interval notation. So it's going to be good practice for when we're solving these to get used to both writing the graph and the interval here. Okay. So you want to practice with both of those. And you'll see it in the homework. It's going to ask for interval notation and for these graphs here as well for the solutions. Okay. So you'll get practice writing both of those. Okay. So that's how we write the solutions for these, both graphing them and with the interval notation. So now what we want to look at is how do I solve these? And they're actually very similar to solving equations. There's only one main difference. When we have one of these inequalities, what we'll see is if you multiply or divide both sides of the inequality by a negative number, you have to change the direction of the inequality. But everything else actually works the same. So adding or subtracting to both sides of the inequality, you can just go ahead and do that. It doesn't change anything. Multiplying or dividing by a positive number, that doesn't change anything either. It's only when you multiply or divide by a negative number that you would have to remember to switch the direction of the inequality there. Okay. But otherwise, everything is the same as just solving an equation. You're just trying to get the variable that you're interested in by itself. Okay, so pretty similar with just that one little change there. So to solve these, we have an addition and a subtraction property of inequalities. Okay, which just says, so for numbers a, b, and c, if a is less than b, then a plus c is less than b plus c, or if a is less than b, then a minus c is less than b minus c. Okay, so whatever the original relationship is here, these quantities a and b, if you add or subtract the same quantity on each side of the inequality, the same inequality is maintained. So again, what that lets us do, it lets us push symbols around these inequalities, right? Because we're trying to get our variable by itself. So we can add or subtract terms on both sides of these inequalities, and we still maintain the original relationship. Okay, so that lets us solve these problems. Okay, so just for example, very simply, if I have x plus 6 is less than 10, I can subtract the 6 from both sides here, and I still maintain this inequality, and I would get x is less than 4, okay? And that would be my solution there. Okay. And then if I wanted to graph this and write the solution in interval notation, we can do that. So the graph would be this. So everything less than 4, let's say 0 is here, 4 is here. So everything less than 4, we'll shade all this, and then we use the parentheses notation there. So that would be our graph. Then the interval, for the interval notation, well, that would be negative infinity to 4 with the parentheses there. So this addition subtraction property, all it says, you can add or subtract terms on both sides of the inequality, and you're good. Okay. Now for multiplication and division, as I said, if the number you're multiplying or dividing by on both sides of the inequality, if it's positive, everything just works as you already expect. So I'm going to break it up into two cases, when the number you're multiplying or dividing by is positive and when it's negative. Okay. So again, the negative case is the one you have to be careful with. If it's a positive quantity, you just go about your business. So we have this multiplication and division property. Of inequalities. Okay, so for numbers, A, B, and C, and as I said, to start, let's say assume C is positive, so C is greater than 0. If that's the case, then we have this. If A is less than B, then I can multiply on both sides, and if that number I multiply with is positive, then we just have this. Then AC is less than BC. Okay, so the inequality sign stays the same. Or I can also divide, so if A is less than B, then A divided by C is less than B divided by C. Okay. So nothing weird or odd here. If the number you're multiplying or dividing by is positive, that all stays the same. So again, a very simple example. If I have 3x is greater than 18, to solve this, well, I can just divide both sides by 3. Since I'm dividing by positive 3, this doesn't change. It just stays the same. So I'm dividing by positive 3, so nothing changes as far as the inequality goes, and we just get x is greater than 6. And we can go ahead and graph this and write the solution in interval notation here. So 6, so let's say 0 is here. 6 can be here. So everything greater than 6, that is to the right with the parenthesis notation. And the interval would then be parenthesis 6 and then infinity, like that. Okay, and then the last part, when C is negative, what happens is when you multiply or divide by the number C, you have to remember to, in that case, you switch the direction of the inequality there. Okay, so multiplication, can't spell. Division property of equality, inequality. So again, for numbers, A A, B, and C. And again, now we're assuming that C is negative. So if A is less than B, then A times C will be greater than B times C. Okay, so the direction changes here, went from less than to greater than. Or if A is less than B, then A divided by C is greater than B divided by C. Now, why is this the case? I'll just give you a simple example for why we need to pay attention to this, why it's important. Let me just start with a basic fact. Okay, so why? Okay, well, let's just say, well, we know 1 is less than 2. You know, that's just true, right? Okay. On my number line here, well, I've got 0, here's negative 1, here's negative 2, here's 1, here's 2. Well, I know everything right is bigger, everything to the left is less, so, I mean, numbers over this way are larger, numbers over here are smaller. If I take this inequality and I multiply both sides by negative 1, what's going to happen? So let's multiply by minus 1. Well, if I multiply each side by negative 1, I'll have negative 1, and I'll leave this open for a second, and that's negative 2. Is negative 1 less than negative 2? No. Negative 2 is to the left of negative 1. Negative 1 is bigger. So we have to remember to change the direction on the inequality here. Otherwise, things don't work out right. So this is just a simple example of why we need to keep track of that. That's important. Okay, so when we're dealing with inequalities, multiply or divide by a negative. Remember to change direction. Now that's only for multiplication or division. Adding or subtracting, you can add or subtract any terms you want to on the inequalities. That doesn't change anything. It's only multiplying or dividing, and only when that's by a negative number. Otherwise, everything basically works the same as just solving a regular equation. Okay, so this is basically the only thing that's different for the most part. So then, just for example, if I have negative 4x is less than or equal to 20. Okay. Well, if I want to solve this, I'm going to divide both sides by negative 4. Since I'm dividing by a negative value, I have to remember to change the direction here. So this would go from less than or equal to greater than or equal to. So divide by minus 4. So that means I would get x is now greater than or equal to 20 by negative 4 is negative 5. So that's the solution then. X is greater than or equal to negative 5. So we can go ahead and graph that real quick. We can say here's 0, here's minus 5. We want everything greater than or equal to, so I could use the square bracket notation there, like this. And then for interval notation, it's negative 5 with a bracket to infinity. Okay. So these are just the basic rules for solving inequalities here. Now we can go and take a look at some examples and solve some more complicated examples. Let's go ahead and take like a 5-minute break. We'll come back. We should be able to finish this section, and that will roughly be it for today. We might do a little bit more, but we'll definitely get through this. Okay, so let's go ahead and solve some inequalities here. So okay, so we've got this. 4m is less than or equal to 9m plus 17. So again, we just want to get m by itself on one side of the inequality here. First, I'll start by subtracting 9m. So 4m minus 9m, we get a negative 5. m is less than or equal to 17. And now, well, we're going to divide by negative 5, so when we divide by that negative 5 there, we have to remember to change the direction of the inequality. So divide by minus 5, and we get m. This was originally less than or equal, so now it's going to be greater than or equal to, and this is just negative 17 over 5. And we would just leave the fraction like that. So now let's go ahead and graph the solution and write the interval down as well. So the graph is this. So let's say 0 is here, and then we'll just put negative 17 over 5 can be there. And we want everything greater than or equal to. So greater than, that means we shade everything to the right. And we use the square bracket to show we're including that number as part of the solution. And then the interval just looks like this. It's bracket, negative 17 over 5, and then infinity, like that. So that is our solution there. Okay. So any questions on that? Okay. Let's do some more. Okay, so we have this inequality. 8p plus 3 times the quantity p minus 12 is all greater than 7p minus 28. So again, what we're going to do is simplify things, get our variable p on one side of the inequality and our constants on the other. So first I want to simplify this side over here, so I need to distribute that 3 and then combine like terms. So I would have 8p plus, distributing, this would be 3p minus 36 is greater than 7p minus 28. Okay, and then the 8p and 3p gives you 11p minus 36 is greater than 7p minus 28. Okay, now I'm going to get my p's over on the left here, so I'm going to subtract 7p from both sides. So 11 minus 7, we get 4p minus 36 is greater than negative 28. Now we just want to add 36 to both sides of the inequality. So I get 4p is greater than 36 minus 28 is 8. Then divide by 4. And since that's a positive 4 there, we just keep the same direction on the inequality, so we get p is greater than 2. Okay, so that's our solution. P is greater than 2. Let's go ahead and graph that. So here's the graph. There's 0, there's 2. We want everything to the right of 2, and we use the parentheses there because that's a strict inequality. And then the interval is 2 to infinity. So that is the solution. Okay, questions on that? Okay. Okay. Okay, so I've got this inequality here. And when fractions show up in inequalities, we're going to do the same thing we would for an equation. So we want to get rid of the fractions. So we're going to multiply both sides by the LCD. So the LCD here is what? 24. Now we're going to multiply both sides by positive 24. So since we're going to multiply by a positive, the inequality will stay the same direction. So we're just going to multiply both sides by 24. So I would have 24 times a third x minus an eighth x is greater 24 times 5 over 24x plus 3/4. Distributing, I'll write this as 24 over 1 times 1/3 x minus 24 over 1 times 1/8 x is greater than 24 over 1 times 5 over 24x plus 24 over 1 times 3 over 4. Okay. Now I'm just going to simplify each of these terms. So here 3 drops out, and this is going to be 8. So this term is 8x. Here the 8 drops out, and that's 3, so this is 3x, so it's minus 3x. And then this is all greater than. Here the 24's drop out, so it's 5x. And then here, the 4's drop out. I'm sorry, yeah, the 4 drops out, and that is 6. So that is 18. Now see what happens here. 8x minus 3x, that's 5x, is greater than 5x plus 18. Well, now when I subtract 5x, I get 0 is greater than 18. So what does that tell us? Not true, right? So we saw this before with equations, right? Sometimes we would get statements that were always true or never true. And one meant, if the statement was always true, we had infinite solutions. If the statement was never true, we had no solutions. Well, this is a false statement, right? There's no value of x we could pick that would make that inequality true. So just like with equations, with inequalities, we can also get cases where we might have no solution, or the solution might be the whole number line. Okay. Well, this is the case where there's no solution here. So This is a false statement, so this is false. So that means we have no solution in this case. Okay, so that can happen with inequalities as well as equations. We saw that last week as well. So you can see things like this in the homework. That can happen. Okay. Let's try. Let's do a couple more. Okay, so let's solve this. Okay, so we have this inequality. 9u plus 5 times the quantity 2u minus 5 is greater than or equal to 12 times u minus 1 plus 7u. So go ahead and solve that and see what you get. False? Okay. Okay. Yeah, so we get no solution here again. So yeah, when we distribute, simplify each side, so we would get 9u plus, and this would be 10u minus 25. It's greater than or equal. Distributing here would be 12u minus 12 plus 7u. So here we would get 19u minus 25 is greater than or equal. The 12u and the 7u again is 19u minus 12. So when you go to subtract the 19u, you get negative 25 is greater than or equal to negative 12. But we know that's false because, again, on the number line, negative 25, that's farther to the left than the negative 12. So negative 25 is actually less than negative 12. So yeah, this is false. So it's no solution. Okay, last little bit here is just being able to write out, go from words to writing out an inequality and then solving it. So if I say that 5 times a number is at least 36. So let's take this one piece at a time. So when I say 5 times a number, what would I want to write here? X times 5, yeah. So I could write 5x. And then when I say is at least, what does that mean?
Greater than or equal to?
Yeah, greater than or equal to. At least means, well, it's 36 or bigger. So I would write greater than or equal to 36. like that. And then we can solve this pretty straightforward, just divide by 5 in this case. So you get x is greater than or equal to 36 over 5. And we can go ahead and graph that and write the solution. So let's say here's 0, here's 36 over 5. We're greater than or equal to, so we want our bracket, and then we shade to the right. And then the interval is 36 over 5 to infinity. Okay. Questions on that? Okay. Okay, so if we say 6 more than a number is at most 15. So when I write 6 more than a number, how could I write that? 6 plus x. And then is at most 15, I would write what? At less than or equal to, right? Because it's saying at most 15, that means 15 is the largest it could be, so it's got to be less than or equal to 15. Like that. So we can solve this. So we get x is less than or equal to 9. So let's say here's 0, here's 9. Now we're less than or equal, so again use the bracket, and then we're shading to the left because we want less than. And then the interval would be negative infinity to 9 with the bracket. Okay. Any questions on that? Seems all right. Okay, so we are done with Chapter 2, so I think we'll stop here for today. So are there questions on anything? Right now? Okay. Then I will see you next week. So remember our first exam, we said, I think I said February 7th, so that's 2 weeks from today. So we'll get a good portion of the way through Chapter 3 next week. So whatever we finish covering next week, it'll be, all of the stuff in Chapter 2, and then whatever we finish covering next week will be what's on the exam 2 weeks from now. So whatever new we talk about on exam day, that new material on the day of the exam won't be on the exam, okay? Okay, you all have a good week. I will see you next Friday.
The following audio recording has been designed for learning purposes only. Do not share, distribute, or provide any type of copies, or this audio lesson will not be made available to you.